A bow-ramped boat born in New Orleans turned surf zone chaos into a conveyor of victory. From Guadalcanal to Normandy, how simple engineering and a crisp playbook rewrote the war and still teaches the 21st century. Amphibious assault on an open beach means troops have to come ashore where there's no port, no pier, nothing civilized, just surf, reefs, and sand that quickly turns into craters. In the interwar period, everyone understood the goal but lacked a reliable procedure. Transports could carry people only to the area, and then the lottery began. Ships, boats, and barges under fire, slow disembarkation over the sides, bogging in the surf, units straggling along the shore, loss of tempo, giving the enemy time to bring up reserves. The failure mechanism was systemic. No standardized boat, no thought-out unloading cycle, no tight integration of ship, shallows, beach. Textbooks of the day looked for answers in ports. The reality of the Pacific and its scattered archipelagos demanded something else. The U.S. Navy and Marine Corps felt their way toward an answer in the fleet landing exercises of the 1930s. Those drills neatly exposed the choke points. First, time. Approach, turn, unload, and back out took forever, because troops had to climb over the gunnels and jump into chest-deep water, snagging their gear and losing rifles in formation. Second, vulnerability. Every second in the surf under enemy machine gun fire translated into extra casualties. Third, control. Ad hoc flotillas of mismatched boats didn't fit a wave-by-wave timetable, which meant fire support and air cover couldn't stay synchronized. What was needed was a tool that stitched doctrine to practice, a uniform boat with predictable characteristics, designed specifically for attacking an open beach. In civilian Louisiana, such a tool was already being born for a very different job. Boat builder Andrew Higgins made maneuverable Eureka swamp craft for oilmen and loggers. Shallow draft, a flat bottom with longitudinal runners, and a propeller tucked into a tunnel so it wouldn't snag on snags. Those traits were perfect for shoals, bars, and surf. The military noticed that Eureka could punch through a surf line and beach almost on the water's edge. But the early versions had a fatal flaw. A solid bow. Infantry still had to climb over the sides. In training landings that cost precious minutes. In combat it cost lives. What came next was the decisive evolutionary fork, where an engineering tweak multiplied combat power. The idea was simple and brilliant. Replace the solid bow with a drop-down ramp. Now the boat lowers its ramp on the beach and an entire squad pours forward in seconds, keeping formation and their weapons dry. Tactically, it means the first echelon shifts faster from target on the water to dispersed in cover, cutting exposure in the deadliest zone, the surf belt. Logistically, a rhythm appears. In, dump, out, repeat. That shuttle became the heart of the Amphibious Playbook, hence the path from LCPL to LCVP. The LCPL, landing craft, personnel, large, still made troops exit over the sides. A compromise between old lifeboat logic and the new surf environment. The LCVP, landing craft vehicle, personnel, made the ramp the rule, not the exception. The design philosophy was ruthlessly practical. A plywood and hardwood hull on frames, a steel ramp, and a minimum of anything that couldn't be produced or repaired quickly. The flat bottom and propeller tunnel let the boat nose right up to shore and avoid vacuuming sand on the way out. Gun mounts on the coamings suppressed beach strongpoints during the critical unloading moments. Key numbers worth anchoring in the text. Length about 11 meters, 36 feet. Beam roughly 3.3 meters, 11 feet. Payload, up to a platoon, about 30 to 36 men, or a jeep plus a squad and crates. Shallow draft, on the order of 2 to 3 feet under load, giving a chance to skip over bars where barges grounded. Power plant, a gray marine 6 to 71 diesel, an inline 6 derived from a GM industrial engine, roughly 225 horsepower in service. Speed around 11 to 12 knots in clean water and less in the surf. This home-built-looking engineering was in fact a time machine optimized for seconds, and seconds are always in short supply on a fire-swept beach. A nearly detective story thread was the Japanese connection. In the mid-1930s, the Japanese Army used bow-ramped Daihatsu landing craft in China. U.S. Marines watching those landings took photos and drew conclusions. In the reports appears a future Marine Corps legend, Victor Krulak. He didn't just describe what he saw. He emphasized the key point. The ramp radically shortens the phase when a soldier is exposed to fire, and preserves formation as men leave the boat. Those materials circulated through staffs and, in effect, green-lit what was already in the air at Higgins's yards. Make the swamp bow combat functional. Sometimes the enemy suggests the technology. Doctrine's strength is to turn foreign observation into a domestic advantage. Why did the ramp become such a force multiplier? First, it removes the gunwale bottleneck. Instead of one or two narrow exits, the entire bow becomes a wide door. Second, it sets movement immediately forward, not down sideways forward, which psychologically eases the dash through spray and explosions. Third, it loves cargo. A jeep, mortar crates, man-portable radios. Everything rolls or is carried straight out without acrobatics. Fourth, it shortens time beached, and thus the chance the boat gets bracketed by mortar fire. Materials and layout were part of the solution, not penny pinching. A wooden hull can be farmed out to hundreds of carpenters. Wood absorbs some shock when grounding, and is easy to repair on the beach. Steel went where shape and toughness mattered, into the ramp and high-stress joints. Today we'd call that a task-rational structure. Shallow draft and a prop tunnel answered the Pacific's reefs and sandbars. A protected shaft line reduced the risk of becoming a dead target for lack of thrust in the worst possible spot. In the end, the LCVP tied together three levels: strategic, assaulting coasts without ports; operational, sustaining wave schedules and landing tempo; and tactical, surviving the first minutes. Interwar failures taught the Navy and Marines to count minutes and meters, not just tons and miles. Higgins's Eureka gave them a platform on which to write a clear playbook. Standardize the boat. Standardize the process. Win time. Survive the surf. Build the beachhead. In 1938, Higgins Industries was a small shipyard with fewer than 75 employees. 5 years later, it had become a network of 7 to 8 sites across New Orleans, employing more than 20,000 people and turning out hundreds of hulls per month. Such explosive growth doesn't happen by itself. It was driven by three things: standardization, logistics, and a forward-leaning personnel policy that removed bottlenecks on the line. Higgins turned the swamp river, Eureka, into a mass-produced landing craft and built an industrial ecosystem around it, capable of delivering not just people to the fleet, but finished products in waves. Standardization. The core principle was design for the task, not the catalog. The LCVP's hull was rationally stitched from wood with metal fittings where it had to take the impact of surf or hold the geometry of the ramp. That wasn't thrift. It was engineering that let production be split among crews. Framing, planking, ramp, power plant, armament. Parts and sections moved between shops on a schedule, and assembly ran on parallel lines. The beauty of this approach was high trainability. A carpenter planing a shear plank yesterday could be assembling frames on the next line tomorrow. Add unified fasteners and templates, and the boat becomes a true product, not a one-off artisan's piece. At its peak, Higgins's yards were turning out up to 700 craft of various types per month. Wood, glue, and steel doing what sounds like a magic trick, except there was no time for tricks. A war was on, and every boat immediately found its place in a loading queue. Licensing and cooperation. Higgins didn't keep production to himself. Other contractors built his designs. This explains why the overall LCVP figure goes over 23,000 across all manufacturers, while Higgins Industries' own sites delivered more than 20,000 landing craft of various types by war's end, of which about 12,500 were Higgins built. LCVPs, an open drawings under controlled standards model, removed the front's dependency on a single yard. Let 1,000 carpenters in different states cut the same longitudinals to the same tolerance. In this way, the landing playbook became not only doctrine but also a supply specification. Logistics. You can read New Orleans on a map as clearly as any staff memo. River, canals, a seaward outlet, rail lines, shipyards on the industrial canal. An ideal node. Higgins spread production across a cluster of plants. Some specialized in hulls, others in powertrains, still others in metalwork and ramps. A conveyor of semi-finished parts ran among them by truck and barge. The secret of tempo was there. Don't chase a single perfect line. Build a swarm of lines, each tuned to its operation. When one place lacked hands or materials, the load shifted to another. This multi-site, elastic factory responded quickly to Navy orders. Need LCMs, change priorities. Need PT output, switch the docks. By 1943, a company recently small had become Louisiana's largest employer and a civic symbol. Social engineering. Higgins's boldest move wasn't technological, but human. Young men went to the front, so the yards lacked hands. The answer was to hire everyone able to work and pay for the job, not for skin color or gender. On the lines, men and women, black and white workers, older people and people with disabilities worked side by side. It was New Orleans's first fully integrated industrial workforce, with pay leveled by position rather than by group. The prejudice-free factory culture wasn't just a fine slogan. It translated directly into output. When crew recruitment reaches beyond usual labor pools, the master schedule fills faster, shifts are covered, and the delivery rhythm becomes steadier. A federal backdrop helped, the presidential order banning discrimination in defense industries, but in practice it came down to the owner's will. Either you build such lines or you don't. Higgins did, and the city answered with work, numbers and mix. By the end of the war, total landing craft output under the Higgins name, including LCVPs and LCMs, exceeded 20,000. Within that pie, roughly 12,500 LCVPs were built by Higgins in New Orleans, while total U.S. production of LCVPs across all plants topped 23,000. The distinction matters. 23,000 is the broader Allied industrial pool. 12,500 is New Orleans's specific contribution. Beyond LCVPs, Higgins produced LCMs, the cargo workhorse that carried light tanks, guns, and freight. The LCM share is especially visible in campaigns where the shore demanded heavy kit right after the first wave. Finally, a separate line, fast PT boats. Higgins built 199 of the 78-foot class, a notable share of the U.S. PT fleet, about 533 in total across manufacturers. This portfolio, landing craft plus torpedo boats, shows the yards weren't single product. Assortment flexibility kept utilization high and smoothed demand spikes. Why did this beat classic big yard shipbuilding? The answer lies in the scale and granularity of the processes. A large steel yard thinks in hulls and blocks. Higgins broke the boat into small wins, each step doable by an averagely skilled worker after brief training. That sharply reduced ramp-up time for newcomers and raised resilience to turnover. Wood and glued structures also enabled parallelism. While one crew installed a Gray Marine 6-71 and rigged the shafting, another prepped the next ramp. While a third primed and painted, a fourth tested ramp action and swapped worn rollers. The result wasn't a record day, but a record week, then month. Layer that tempo onto a city logistics hub, and you get what strategists call production power in the decisive place at the decisive hour. Integration as an edge. Equal pay and mixed crews are often told as a moral triumph, and they are. But there was hard pragmatism. Integration removed hiring bottlenecks and reduced shop floor friction when rules were clear and shared. In the WWII era, the struggle of Black Americans for a double victory over fascism and racism, Higgins's lines look like a piece of the future, where what mattered was holding tolerance, not a checkbox on a form. Such a climate not only keeps people but also speeds newcomers' mastery of complex operations. Social and technological modernization walked in step, multiplying output together. Scale effect. On the war, each LCVP shipped wasn't just a boat but one cell in the landing grid. It brought a platoon, a radio-equipped jeep, a mortar team to the beach. When there are thousands of such cells, a staff can draw waves with precision measured in minutes and ship coordinates. That's possible only with a predictable rear. This is why generals spoke of Higgins with gratitude. Not because the boat was pretty, but because it was available, in the needed quantity and on time, which in the military equation can matter more than any superweapon. A production line that began with 70 workers on the waterfront, unfolded into tens of thousands of lives in rhythm, and delivered the very speed of advance, without which doctrine remains a book of diagrams. The Amphibious Playbook, Doctrine and Tactics. An amphibious operation doesn't begin with the first splash at the shoreline. It starts where no one is shooting, with reconnaissance. Doctrine FTP 167 breaks this prosaic truth into stages the way a mechanic breaks an engine into parts. First comes gathering data on the coastline. Depth contours, type of bottom, surf angles, currents, tides. usable gaps in the reefs, and possible avenues for flanking the defender. Hydrographers mark the landing areas. Marines and scouts sniff the shore for pillboxes and gun positions, and aircraft photograph under every kind of sun. Then comes fire suppression. Battleships cruisers cut windows into the coast by silencing batteries and communications nodes. Dive bombers and attack planes slice roads and the approaches for reserves. Third is deploying the waves. Assault transports put boat groups into assembly areas. On the water, everything obeys clocks, flags, signal lamps, and a simple rule. A straight front is cleaner and more survivable than a ragged one. Beaches are labeled with colors and letters. Approach and egress lanes are marked with buoys and smoke. And on the sand itself stand the beachmasters, the people who turn surf chaos into a moving conveyor. Control is the playbook's nervous system. In this battle score, there are conductors, the landing control ships, boat group commanders, wave commanders, beachmasters, and beach unloading officers. Each has a communications channel. Each is tied to H-hour and to the LD, line of departure, from which the waves begin their sprint to the shore. The boat flotilla forms into fans and advances in ordered lines so the surf line meets not a crowd, but an organized front. Discipline here decides everything. An extra minute at the water's edge is paid for in blood. Next comes the central logistics question. Who follows whom? Here the doctrine is strict, because improvisation costs lives. Riding the outer anchorage are the LSTs, the motherships, whose holds carry gear and troops. They are warehouses, barracks, and the iron stomach of the operation. From the LSTs, via ramps or booms, the working boats go into the water. LCMs and LCVPs. The LCM is the surfside truck hauling guns, tractors, light tanks, and crates. The LCVP is the taxi for platoons and for jeeps with radios, engineers, and medics, where the coast is harsh and a jagged belt of reef lies between ship and sand. LVTs, tracked amphibians that don't argue with coral, are added to carry infantry straight across obstacles. That sequence is no whim. Infantry secures the foothold. LVTs and LCMs bring in the heavy stuff. LCVPs shuttle people and light equipment, and LSTs remain floating warehouses, feeding a continuous stream. The shuttle cycle is the heart of the playbook. From the assembly area, the boats move to the LD, align, dash for the beach, throttle back in the shallows, catch a crest, touch bow to bottom, ramp down, and the whole platoon pours onto the sand in a straight line. On an ideal beach, the time standard from touch to backing off is measured in minutes. You can't dawdle. Mortar and machine gun fire almost always arrives. On egress, the coxswain drops a stern power. The tunnel-protected prop doesn't hoover sand. The boat rides off the wave and slips out through its assigned lane. Then back, to the LST or the designated transport, to pick up the next platoon. Crates of ammunition, water, radios, sometimes wounded on the return. This rhythm is the beachhead's circulation. Lose the rhythm, and you get edema and suffocation. The link between tactics and the LCVP's design is concrete. The shallow draft lets the boat slip where a barge would belly out. The propeller tunnel and protected shaft mean fewer chances of losing thrust on egress. The screw doesn't plow the bottom or snag roots and rocks, and welded skegs steady the hull in that foaming mash of surf. A fast bow ramp is the key to time on the beach. Instead of a 1x1 queue over the side, there's a wide front of egress, instant dispersion, a smaller target. The gun mounts on the coamings aren't decorative ears. They put heads down in the strong points that rake the landing sector at the moment when men are most vulnerable. A wooden hull? It isn't just about build speed. Wood takes a grounding blow more softly, repairs faster in the field, and doesn't rust where sand chews off paint. FTP 167 also prescribes the micromechanics of the waves. The interval between the first echelons is minutes. The goal is not to smear the front, but to keep feeding it with fresh manpower and metal. The first wave carries assault teams and engineers with Bangalores for wire and hedgehogs. Behind them come reinforcements with light mortars and machine guns, and signalers with long reels of wire. Then comes the dirty logistics: water, ammunition, ponchos, crowbars, matting for vehicles, portable bridging, medical kits. Where the shore allows, DUKWs and ponton sections get going almost at once. Floating piers unfold. so that unloading from the sea no longer depends on the surf's mood swings. All of this becomes a stable chain, only if boats arrive course-bearing time in the right sequence. For that, the flotilla has lanes and control points. Each wave has a number and a leader. Each beach has a senior beachmaster who commands not metaphorically but literally, with flags, an Aldis lamp, radio, and sometimes a megaphone through the wind. The psychology of combat matters here as much as hardware. An LCVP coxswain doesn't just waggle a tiller. He holds his unit's tempo. On his decision, ride this wave 2 more seconds or touch now. Depends whether a platoon lands under a heavy machine gun or pops into a dead ground beneath a lip. The assault troops have a single incantation. Down the ramp, fan out, crawl, breathe, count to 10, start digging. The Beachmasters is different. Clear the lane, wave the boat off. Don't block the next one. The staff's is a third. Don't break the fire plan, and don't let the second wave arrive into a vacuum, or worse, into an unsuppressed kill zone. Recon and suppression come back like a refrain at every turn. If at H-hour the flank battery isn't suppressed, the wave falls under a crossfire. If the reef passage isn't marked, the first boats hang on the teeth, jam the lane, and lose headway. Ideally, ahead of the assault wave go swimmer demolition teams and cutters that remove above-water obstacles. In reality, improvisation is often required. And here the LCVP's design pays off again. With shallow draft and agility, it can find gaps where deeper craft must go through. Doctrine also keeps the return flow in mind. Every LCVP is also an ambulance. On egress, the crew lays casualties down, signals the transport's medics, and returns the boat to the cycle with minimal tempo loss. Here, the Spartan interior is a blessing. Minimal protrusions, maximum clean, flat surfaces. The same ramp that a moment ago launched a platoon now swallows stretchers. Finally, the subtlest element, synchronizing with air and naval guns. The playbook demands that ship and air fire crawl forward exactly as far as the first echelon advances. Too slow, and your own troops slam into a wall of steel. Too fast, and they land on a sector that's wide awake. So each wave has not only a clock but radio windows. Report beaching, request correction, mark the crossing of the first dune. Here again, the LCVP is the perfect gear. Predictable speed, steady handling, a silhouette the spotters understand. Field test, from Guadalcanal to Normandy. Guadalcanal was the first big exam. Boats, rules, people, and an ocean that forgives nothing. In August 1942, LCVPs and their precursors were offloading Marines straight into the blue-gray surf during narrow tidal windows. The growing pains showed at once. The run from ship to assembly areas was longer on real waves than in the manuals. Links between boat group leaders and beachmasters were broken by spray and engine noise. On the way back, many coxswains lost visual contact with their transports and hunted for them by silhouette. Gear packed perfectly for a warehouse turned unruly in the surf. Crates skidded, lines snarled, gasoline drums tried to escape like living things. Yet the doctrine's core assumptions proved out on day one. The LCVP's shallow draft let coxswains nudge the bow into the thinnest patches of shore. The ramp saved seconds, and the boat's sectional construction endured constant keel pounding on sand. After the first 24 hours, staffs were already rewriting the small stuff. More flags and smoke, dedicated egress lanes, training coxswains for blind approaches by compass and time, not just by visual landmarks. 3 months later, on the other side of the world, Operation Torch went in. North Africa, long, low beaches, and a very different density of enemy batteries. There, the discipline of waves and the LCVP's simplicity shone. Ships launched fans that laid along the shoreline like the teeth of a comb. Units used to barges and hoists discovered that the bow ramp removed the bottleneck to a comic degree. A platoon debarked not one by one, but in a front. A radio jeep rolled off by itself without needing half a squad to wrestle it over the side. A new line appeared in the logs, time beached, and staffs began hunting seconds there the way they once hunted ton miles. The real shock came at Tarawa. The coral reefs of Baishio Atoll in November 1943 were an obstacle the manuals had underrated. At low water, LCVPs bellied onto the reef teeth short of the sand strip and became fixed targets. Under fire, troops had to disembark right on the reef edge and make their way in on foot hundreds of meters through waist and chest-deep water. Rifles held high, radios and ammo bundles in tow, boots patched and packed with coral grit. That's where LVT amphibians showed their nature. Their tracks bit into coral, hulls crawled over white crests, and they delivered assault troops where LCVPs could not. The tactical lessons were hard. First, tide intel and windows were not optional but life-critical. Second, wave planning had to account for the reef factor. First echelons and LVTs, with LCVPs bringing follow-on forces once the tide rose. Third, lighter swim loadouts were worked out. Less iron, more waterproof bags, strict initial ammo scales. Fourth, more gun cover boats and smoke to compensate for longer exposure in the kill zone. After Tarawa, many commanders began speaking of the geometry of the beach, almost as an enemy in itself. Terrain stopped being backdrop and became an active player. By summer 1944, the Normandy coast hosted the war's most complex score. D-Day's scale would either validate the playbook or break it. Hundreds of LCVPs moved in controlled flotillas, each with its number, its wave, its beach. On board were platoons, engineers with Bangalores, sappers, weapons teams. In adjacent lines came LCMs hauling DD light tanks, guns, and tractors meant to turn sand into firing positions within hours. On approach to Omaha, all the surf's demons rose. Wind, set, hidden sandbars, a tenacious defense. There the LCVP-LCM comparison is clearest. The LCVP won on tempo. It could come in closer, drop the ramp, and hand itself over to a platoon like an armored bus, then vanish backward in spray. The LCM ran heavier and deeper, but when a tank finally rumbled off and brought a gun to bear on the beach, the infantry gained an instant anchor and cover, and the defender, a new problem. Both boats were needed at once. One made the front alive, the other made it solid. Flotilla organization in the channel turned the shuttle into an art. LD lines were marked by buoys and signal mast boats. Guides held formations like air navigators, by time and course, not by instinct. For Omaha and Utah, extra channels were prepared to reassign waves, because experience said some boats would be set off course and others diverted to reserve due to damage. Beachmasters and unloading officers, often stepping onto sand before many riflemen, immediately laid fascine and plank roads, hung direction boards, and improvised gates for egress corridors. Veterans recalled the sounds that stuck in memory. The gray Marine's clatter and the crack of a dropping ramp. Each one meaning new men, new magazines, new hope. At Sword and Juneau, the shore was kinder than at Omaha, and there the playbook showed its best side. Wave after wave turned the beach into a rhythmic conveyor. In the Mediterranean, steeper shores and tighter coves, the playbook bent without breaking. At Sicily and Salerno, LCVPs used lanes with sharper approach angles, and naval gunfire worked at shorter ranges on steeper trajectories to fire over the hump of the coast. There, LCMs were prized for hauling mountain guns and light vehicles over narrow stone spits. LCVP coxswains learned to ride swell resonance and avoid planting the bow on rock by departing diagonally. The prop tunnel and shallow draft once again kept the boat from becoming a mere prop. Even in tight coves, the cycle of approach, unload, clear could run without jams. At Saipan, the playbook met dense defense in depth and mortar fire reaching the supply bases already forming on the sand. The answer was fine-tuning the waves. First LVTs landed assault troops to bite into the first dunes, and LCVPs began bringing not only men but loose sandbags, hedgehogs, and wire reels for instant fortifications right at the waterline. Beach commanders literally redrew unloading lanes every hour, rerouting around smoke, craters, and fresh debris. The system stayed alive because every unit, boat, jeep, gun team, knew its place and time. Okinawa was the Pacific Theater's culmination, an extended campaign with intermittent storms, rocky shore, and cave defenses. There, the LCVP's reverse logistics came into full force. Mass casualty evacuation and rapid unit rotation through the same corridors used for ammunition flow. The design's resilience showed hidden reserves. After weeks in the surf, boats were repaired on the water's edge, ramp rollers swapped, keel-edge shoes refitted, and they kept working. Carpenters and motormen became as much a part of the beachhead as machine gunners and signalers, a sure sign of a mature system. Comparing theaters points to one conclusion. The playbook wasn't dogma. It was a well-tuned machine with tolerances. At Guadalcanal and in Torch, The emphasis was on tempo and clear hierarchy. At Tarawa, it was on acknowledging limits and bringing in LVTs as icebreakers over the reef. On D-Day, it was an orchestra of hundreds of boats, with LCVPs and LCMs playing different parts of one melody. In Italy, it was work on tight, rocky coasts, where shallow draft mattered as much as armor. At Saipan and Okinawa, it was turning the beach into a living organism, where survival went to those who could redraw corridors every half hour. The phrase "Andrew Higgins is the man who won the war for us," attributed to Eisenhower, has long taken on a life of its own. Historians, used to the cold shower of facts, take it apart the way an engineer strips down an engine. Not a literal truth, but a compact formula for the complex dependence of the front on the rear. A commander of ground forces who lived through a chronic shortage of ton knots could well have said it, in gratitude to the system that turned the doctrine of amphibious assault into a repeatable process. In academic terms, though, it's more accurate to say the war was not won by one person or one boat. Victory came from the resonance of doctrine, industry, and training. As myths do, this one simplified the plot down to a recognizable face and a single wood and steel box. That simplification is useful if we remember it's about causality, not a cult of personality. The boat became a symbol of industrial victory, precisely because its unglamorous hull shows the essential thing, the speed with which an idea becomes a serial product. Behind the symbol stand very material traces. In New Orleans, the National World War II Museum keeps the flame. Its LCVP on a dolly and on the water is a visual tutorial in the geometry of doctrine. In Normandy, displays lower a working ramp before photographs of Omaha Beach. Tourists who have never read a line of FTP 167 instantly grasp why that bow exists. Come in, open, let them out. Along the coasts of Britain and the United States, volunteer shops are at work. Some restore hulls to museum standard. Some assemble running examples from old templates. Some build replicas for historical reenactments. Demonstration landings show better than any lecture slide how a box differs from a barge. Rhythm. The diesel's clatter, the short hiss of a line, the click of a latch, and dozens of boots leave wet tracks on the sand, turning the geometry of the surf into the geometry of a beachhead. The experience is bodily, not a mock-up, but weight, inertia, spray, the vibration of deck planks. Restorations aren't just about "we remember." They're laboratories of solutions. Any running replica must solve old problems under new materials and regulations. Where to keep wood, where to switch to composites, how to ensure spectator safety without breaking the logic of the ramp, what to substitute for unavailable powertrain components. Each compromise is a small lesson in flexible standards. That flexibility was exactly what saved operations in the 1940s. Identical functions could be delivered by a set of interchangeable means, which made the system resilient to supply disruptions. Why did the LCVP stick in memory more than, say, the LCM or the LST? Because it's human scale. Inside, you don't see abstract tonnage statistics, but a concrete platoon. Faces, a sergeant's voice, the thump of rifle stocks on the ramp. The LCVP is the contact point between grand logistics and the first step onto sand. It connects the map's level to the level of breath. It's a rare quality in a machine, to be both tool and image. That's why books and films so often show it. Through it, the meaning of industrial victory becomes clear. When industry is not factories in general, but a sequence of simple operations repeated 1,000 times without failure. Now to the lessons for the 21st century. First, affordability as strategy. Not cheapness, but thoughtful sufficiency. Exactly as many functions as the task requires, and a minimum of fragile complexity. In an age of high-tech systems, this sounds almost heretical. But wars today are also won by tempo and multiplicity. Saturating a theater, in quantity and quickly, demands platforms that can be built in parallel, by the dozen and the hundred, without bottlenecks. The LCVP shows that high throughput comes not from ultra-precise machines, but from breaking the task into trainable steps and applying sensible unification. Second, modularity. The boat was a platform for people, jeeps, mortars, radios. Its useful volume changed purpose from wave to wave. Modern fleets and armies likewise need carriers of functions, not fixed payloads. What carries troops today should carry sensors tomorrow, and generators or drones the day after. Standardized dimensions, mounting interfaces, universal ramps. These let doctrine change shoes on the run. The central thesis: design the module together with the procedure for swapping it, or modularity is fictional. Third, doctrine matched to hardware. FTP 167 didn't just describe the operation's goal. It tied timings and routes to the real speeds and turning radii of specific boats. Today's plans too often do the reverse. Sketch a concept first, then force the hardware to fit. The LCVP's lesson is to write procedures for real platform profiles, not ideal ones. Factor in draft, sea state stability, maintenance resources, and realistic training time. Then the shuttle of the future, whether columns of wing and ground drones, swarms of small boats, amphibious trucks, or autonomous pontoons, becomes the bloodstream of an operation, not a loud metaphor. Fourth, maintainability and distributed support. Wood, simple assemblies, on the beach, repairs. This isn't romanticism, but production strategy. In a world of stretched supply chains, the winner is the one who can keep capability alive, in the field. For today's forces, that means designing components so they can be swapped not by design engineers, but by line techs trained in weeks. Publishing open specifications for consumables. Allowing alternative materials. Let today's plywood be composite, but keep the logic. Maintainability is firepower measured in uptime. Fifth, attritability. Unfussy carriers. You could lose LCVPs and replace them without collapsing the scheme. The digital age analogs are inexpensive unmanned systems, expendable communications buoys, small carrier craft, the ocean's handcarts, assets you can afford to risk. They create event density, overload enemy sensors, and sustain tempo. But, as in the 1940s, they require a conductor. Control networks, schedules, corridors, no less than crew heroism. Sixth, the human factor. The story of the LCVP is the story of coxswains, beach parties, carpenters, motormen. In the 21st century, interfaces must be clear rather than flashy. Training must be reliable procedure, not a glossy video. When an operator has one lever and two intelligible indicators, the system survives chaos better than when he faces a panel of 100 buttons. It's dull, and therefore priceless. Seventh, myth as instrument. A symbol simplifies the complex, focuses will, and mobilizes resources. The danger of myth is complacency. The power of myth is making goals visible. The boat that won the war isn't about a single hero. It's about disciplined execution. If that slogan pushes an engineer toward many, fast, maintainable, and a commander toward time, course, wave, the myth is doing its job. In museums, at reenactments, and in the classrooms of future Marines and sailors, the LCVP remains a modest yet persistent teacher. It reminds us that the genius of war often looks like the right door opening at the right second. Everything else is preparation for that click. When we think about the operations ahead, from Arctic shores to shallow deltas, it's useful to picture lowering one more ramp. What should wait on the far side is not a loud slogan but a proven process, extendable by new technology. In that sense, the Miracle Box's legacy lies not in wood or steel, but in the habit of commanders and engineers to hold doctrine and hardware by the same handle.